Alright, welcome back guys to another casual code talk. So today, again, it's another unscripted video and I literally just picked this up randomly. Oh, I didn't mean to unlike it. We'll see if I want to like it or not after I do it. Okay, so threesome closest. Okay, so I actually just did threesome where you had to sum it to be 0 and find all the triplets that sum to 0 in the vector. So here we're trying to find we are trying to find a triplet a triplet in this vector that sums to not the target but the closest it can to the target, you know? So for this one, the best it could do is 2. So what it returns is 2. It doesn't return the triplet -2, -1, 2, and 1. Okay, so hopefully the problem is clear. If not, you could pause the video and read it a few more times. Okay. So now off to solve it. Okay. So whenever I say that, I get a little nervous, oh shoot, I have no idea how to do this. Okay. So they have to sum to closest. So this is gonna be okay. Always go to the naive solution. That's the best thing to do when you are stuck and don't know the answer immediately. So what you can do is go through all the combinations. So actually the same thing that we did in threesome, where we go through each one of these left to right, and then after let's say we're in this iteration when it's 1, we find basically all the combinations. Not all the combinations. We actually first we sort it so that we know if we go left in the loop we are decreasing our amount, and if we go right in the loop we are increasing our amount. I'm actually gonna try that strategy. Okay, so we have let me sort nums first. So nums begin and nums dot end. And so I would like to have a for loop for int I equals 0, I is less than dot size. And then I remember this cool optimization by doing -2 because you can't have a triplet when you're already at the second to last element, right? Okay, so because we're finding triplets starting at the first element and going to the last one. Okay, so then I kind of like this. I'm gonna say int. So I'm kind of basing it off of a solution that I just looked at for threesome. So int a is gonna get nums at I, and then what we could say is if I oh wait, yeah. So actually, so if a is greater than the target, we're done. We're donezo here because why can't I type? Because this is sorted, so they're only gonna get bigger. And so if wait a second, we want the closest one, don't we? Okay, forget this. This is not important. So if I is greater than 0 and that I -1. So if it equaled the previous one, just continue. I want to only look at the first of a repeated number and then skip the rest. So I'm just going to continue if we get here. And notice how I put the I is greater than 0 so that if it's the first element, I will always allow that. And then if the first element is repeated more than once, I'm going to skip all of those until we get to the next new element. And then if it's a new element, then like this number is not going to equal this number. And so the first iteration of the new element is going to go through, and then if that new element has repetitions, those are going to be skipped also. And yeah, okay. So then I kind of like this for loop int j equals I plus 1, and then k equals nums dot size minus 1. Notice how I can use now the last element. It's not like I can't have it in the sum. You know, like this was just because like if I got to here, then there would only be 2 elements left to choose. I can use the last element. Like, yeah. So then as long as yeah, j is less than k. And then, whoops, lowercase k, and then I will be incrementing them when I feel like it, not over here. Okay. So, k. What was I gonna do? Oh, okay, I'm gonna need a min. I'm gonna need an int min equals, no, this is gonna be like, literally, let's just make this int max, whatever. And then this is actually the exact thing I'm going to be returning. Return min. Okay. So some points, hopefully, the interviewer is going to see you got some grasp on this. Okay. So then what I'm going to do is say b equals, like I'm usually one for a little cuter, a little more concise code. But, you know, these problems are sometimes really hard, so it helps to write them out like this. Okay, so those are the 2 numbers, and then, like, the value is going to be the sum of those. Okay, so if the value is, sorry, if the value minus the min, no. If the value minus the target, how do I get absolute values? Okay. You go to absolute value C++. I really like this reference thing. Oh shoot, wait, I don't even think my AirPods are on right now, are they? Oh good. Nice. Is that it? You just do abs? I feel like they're gonna make me do like STD here or something. Let's see. So if the absolute value of that is less than the absolute value of min minus target, and obviously it will be for the first iteration, then min gets value. Okay, and then to avoid, you know, I actually don't even need this. This is just for optimization. So actually, I'm going to take this out for now. So unlike the threesome where I can't have duplicates, I can get a duplicate and then the min just doesn't change really. So in a sense, this one is easier. And I think this might be done. Okay, so let's see. So for I, it's going through all those. And for J gets that. And Oh, well. So now I have to think of where to increment J and K. So if it's less than it, I'm not sure what to... Oh, I know. Okay. So if value is less than the target, then if the value is less than the target, then I'm going to want my J to increment. Else I'm gonna want my K to decrement. Right, because if the value is less than it, then all my low values are on the left side, and J is gonna plus to get there. And so this is gonna be if the value is greater than or equal to, then I want the big value to go down. And I think it's okay to be greater than or equal to because this guy is running every time. Now, I'm sure there's some optimization things that I could be doing here, but for now, I think this is fine. Like optimizations in the sense of like, if I get to 0, or sorry, wait. Yeah. If I get the min to like equal the target, I should just return the target. And then be done with this. Like some stuff like that. But let me just see how this works. Okay, so we got, oh, I did not declare these. I feel like they're gonna, okay, that's a good sign. I probably forgot some, so I returned the max int. How could that possibly not be true for the first one? So so obviously it didn't get into this.
Nothing to do with you. Yeah, just that one will be fine.
For loop, but it must have gotten in this for loop, and then I plus 1. So like, let's just look at the first. So we got 1 for A, and then we're getting 1 and 3. So the value is going to be 5 here. So if the absolute value minus target, so it's going to be 5 minus 1, so that's going to be 6, is less than, like, obviously this is true. Why would that not have got there? That's a bit weird to me. I want to see if it actually does get here, so this is something I kind of do sometimes to decode, but not like get too into it. And also there's like, I don't actually know how to work this debugger. Oh, wait, hold up. That's not what I wanted to look at. Nope, 1 second. I don't know if this is actually getting here or not. Test case. Let's copy this buddy here. Weird, it's not getting here. This is literally the max. How could it not get here? I feel like it's not even getting here. Now I'm gonna have to say got to first loop. Or I guess this is second. To loop. And then run code. Okay, it is definitely getting to the second loop. That is so weird. Why would that... How could the value be that far away from the target? What the hell is this value? It's gotta be abs. Okay, cout value space value, and then I want to also see abs val minus target, and that's going to equal whatever that is abs. Oh, I guess I should do that. Okay. Value is 1, abs is 2, that's great. -1, okay. So why are they not entering here? Okay, so next thing to check is what is... Okay. This might... I think it's because it might overflow if this is a negative number. So I think something that we can do is just say nums 0 plus nums 1 plus nums 2. I think we can get rid of these. And one thing that I wanted to add here was it's a 3-sum. What are you supposed to do if there's not enough numbers? So the sum is exactly, return the sum of the 3. You may assume each input has exactly what you may assume each input would have exactly one solution. Yeah, it's hard to tell what you'd output if there's not. Okay, let's see. Okay, there we go, but that's not the right. Oh, nice. Yay. Huh. I didn't think I'd be able to do it so fast. Okay, so we're at the 34th percentile. I have some optimizations here. So if min equals target, we can just return target or min. I mean, they equal each other, whatever. So that's one optimization. Let's see where that gets us. It's pending. I could speed up if I pay $35 a month, which I might do, not because I want this, not because I think that'll help so much, but like I kind of want to support this Leetcode. They're pretty good. It's a pretty nice thing, and it also never takes this long. So I guess there's a lot of people who submitted today. Okay, anyway, so we could think of some other optimizations while that's loading. Okay. So I think this is a fair optimization. And then actually similar thing here. We could do if b equals wait, hold up. If b equals nums j plus 1, then I think we can continue, and if
What are you saying about Iceland? Nothing. I didn't know you were listening. Well, don't. Please don't. It bothers me. But I'll tell you another time.
yeah, and then we could do if c equals num.
One has nothing to do with the other. I'm sparing you feelings that you have nothing to feel. Oh, yeah.
Minus 1. So if it equaled the previous one, or the one, yeah, in front of it, then we can continue also. Okay, I'm kind of scared it's going to delete it if I refresh, so. Okay. Okay, so I don't want to put these in right now. So before, if it was at 34th percentile, I added this line 17, and wow, I got to the 99th percentile. So that's a pretty big optimization there. I'm not sure if these, I feel like this one's correct. It's like, I feel like I'm not thinking of some edge cases. Like, let's see where this gets us. I feel like this, I might have fucked it up here, but. Oh yeah, they're all equal. True. Yeah, get rid of these. Get rid of them. I like my 99 percentile before. Okay. Bye and goodbye. Okay. I just want to get it up to there. What? This was literally the same thing I just submitted you. Okay, there we go. So I guess it depends on the time of day you submit it, but I mean, this I could tell would give you a huge optimization. Okay, well, I hope you enjoyed this casual Leetcode talk. I will try to solve another one next time. Okay, see ya, bye.